What if I told you that the iron in your blood and the calcium in your bones were once forged inside exploding stars? Yes, every bright star in the night sky has a life story. Stars are not eternal. They are born, they evolve for billions of years, and eventually they die. But where does a star actually begin its life? And what determines how that star will ultimately end? Every star begins inside a nebula, a vast and cold cloud made mainly of hydrogen gas, helium, and cosmic dust. These enormous clouds drift through space for millions of years. Under the pull of gravity, parts of the cloud slowly collapse toward the center. Astronomers call these regions stellar nurseries because this is where new stars are born. As gravity pulls gas and dust together, the central region becomes denser and hotter. This early forming object is called a protostar. Gravity keeps compressing the gas further. As a result, the temperature and pressure inside the core increase dramatically. When the core temperature reaches several million degrees, hydrogen atoms begin fusing together to form helium. This process is known as nuclear fusion. Fusion releases enormous amounts of energy in the form of heat and light. At that moment, a true star is born. After fusion begins, the star enters the main sequence, the longest and most stable stage of its life. During this phase, hydrogen in the core continuously fuses into helium. The energy produced balances the inward pull of gravity and keeps the star stable. Our Sun is currently in this phase. Low-mass stars burn fuel slowly, so they can live for tens of billions of years. Massive stars burn fuel rapidly, so their lifetimes are much shorter. Eventually, the hydrogen fuel in the core becomes depleted. The core contracts under gravity, while the outer layers expand outward. The star becomes much larger and cooler at the surface. At this stage, it transforms into a red giant, or in the case of extremely massive stars, a supergiant. The final fate of a star depends mainly on its mass. Stars similar in mass to our Sun slowly shed their outer layers into space. The remaining dense core becomes a white dwarf. However, very massive stars end their lives in a powerful supernova explosion. After the explosion, the collapsed core may form a neutron star, or even a black hole. The life cycle of a star is a cosmic journey lasting billions of years. Whether a star fades quietly or ends in a violent explosion depends entirely on its mass. But every stellar death spreads heavy elements throughout the universe. Those elements eventually form new stars, new planets, and even life itself.